Hello. In this video, I'll give you a brief introduction on diagnosing cars using the ABLogger. As you might know, ABLogger is the device intended for diagnosing electrical onboard systems of any vehicles. You can install the ABLogger on your car for 2 days and use your car as usual. This is extremely helpful for finding out problems which only appear while driving. ABLogger is extremely useful for detecting so-called floating defects, which are hard to detect during the service. Cars, bikes, warehouse machinery, and even business jets. We have tested ABLogger everywhere, and it helped to detect lots of problems. Device installation is described in the user manual, but the core idea is simple. Just connect ABLogger to the battery via this yellow socket, and then put your system power wire to the sensor. Please note that sometimes there's a lot of wires connected to the one battery pole, so for correct measurements you have to put all these wires to the sensor of the ABLogger device. Current direction actually matters. As you can see, there's an arrow and 2 connection diagrams engraved on the ABLogger body. These connection diagrams show ABLogger installation on either positive or negative power wire. But once again, don't worry about it too much. If you'll mess up the wiring, the ABLogger will still record data. But since current direction matters, the charge current will appear as discharge current and vice versa. You can easily fix it in the software by simply inverting the current graph. Important things to consider. First things first, remember that ABLogger can operate normally in range from 7 to 90 volts. And if the voltage exceeds 95 volts, ABLogger internal circuitry might be damaged. Hence, ABLogger is not suitable for installation on hybrid or full electric cars, because the usual voltage levels there is way higher than 95 volts. An additional important note, nominal voltage is less than the actual voltage. The battery with 12 volts of nominal voltage, if it's charged, has about 12.8 volts. While it's being charged by the car's alternator, the voltage is about 14.4 volts. Always keep it in mind. And the last note I have to make is all about leakage current measurements. The leakage current is the current consumed by car's onboard system when the engine and all possible systems are turned off. Normally, the leakage current should be about from 20 to 30 milliamps, but ABLogger is a small single sensor device, and it's impossible to measure hundreds of amps and tenths of milliamps with same accuracy. The minimum current ABLogger can accurately measure is 100 milliamps. So, if during leakage current measurement you see the current value several times higher than 100 milliamps, it might be a problem with the high leakage. The possible reasons of high leakage are bad wiring and oxidation, high consumption of some part of the system, or incorrectly installed alarm system. All data obtained by ABLogger device recorded into the internal memory and then transferred to PC via USB interface. It is also possible to transfer measured data via USB in real time. The software is called DataViewer. This software is intended for visualizing data obtained by ABLogger. The software is also able to generate diagnostic reports. The software has built-in help, so you use it if needed. Everything important described here. First, let's open a data file. Just click Open File and select one. It will take some time to process data. And that's it. As you can see, there's a window containing 2 GraphView ports, upper GraphView port and the lower GraphView port. And there's a drag and drop tag section. So tags are just quantities which are either measured or calculated by the ABLogger. So if you drag and drop any tag into the drag and drop tag section, it will appear on the graph. You can toggle its visibility, and if needed you can adjust its color. Let's take that beautiful green color, click set color, and that's it, the color is changed. If the tag is not needed anymore, it can be deleted. Just select the tag and press delete, and that's it. Well, now let's analyze what we're seeing here. In the upper graph viewport we have voltage graph, and in the lower one we have current graph. Alright, we can even zoom in so we can see in detail, and we have to learn how to analyze graphs. Well, it's quite simple. There are just two basic graphs which should be well known and understood. And see these two graphs, current and voltage. And what we can see here is the current is positive, so it's above 0. The curve shape doesn't matter, but if the current is above 0 and the voltage rises, that's the charge. Quite obvious. And the second one, if the current is below 0, so it's less than 0, once more, shape doesn't matter, and the voltage goes down, that's how the discharge looks like. That's quite obvious, but the basics should be known and understood well. Now let's talk about viewport navigation. You can move along the timeline by simply holding left mouse button and dragging your mouse right or left. That's how you pan the graph. To scale the graph along the timeline, hold right mouse button and move mouse left or right. You can also use the control button and your mouse wheel. That's how you scale along the timeline. If you want to scale the graph along the tag value axis, obviously that's the Y axis, hold right mouse button and move your mouse up and down. You can also hold shift button and use your mouse wheel. That's it. If you want to zoom to exact area of the graph, you can hold alt button and then press your left mouse and select the area you want to zoom to. That's quite simple. But if you want to get back to the overall graph view, you can just hold alt and click anywhere, and that's it. Now you see the whole graph. There are additional tools available: markers and local values. Markers are just the lines you can use and move them along the timeline. These are T1 and T2 markers. You can move them along the timeline, just click and drag, that's it. And there are also value markers, V1 and V2. You can also enable them and move. That's quite simple. And there's another feature called local value. If you click it, it will show you the maximum, the minimum, and the average value within the displayed area of the graph. And that's quite handy when you want to find your peaks or drops. For example, when you start the engine, it consumes a lot of current, right? So here in the current graph viewport, we can enable local value feature. It'll think and see. It just find our max and min points, and they're all displayed here. So at max, when engine is being started, the spark generators consume about -200 amps. That's it. Quite handy. Well, now let's analyze data updated from different cars. And first let's open file. I don't know, select Impreza maybe. Click open. It will load the data, and that's it. Well, I'll tell you the truth in advance. We're examining an ideal case here. On the current graph, let's enable the local value feature. And that's it. See, the minimal value is about minus 242 amps. Obviously, this is the current consumed during the engine start. And minus 242 is quite okay, nothing abnormal. Let's enable local value for voltage tech as well, and see minimal voltage is about 10.84 volts, and obviously the lowest voltage we see when the engine is being started as well. So everything is okay. Let's now check the leakage current. I remind you that the leakage current is current consumed when the engine and all possible systems are off. Well, let's zoom in, maybe here after the right. I remind you, I hold Alt and just select the region I want to zoom to. Okay, and then I just hold Shift, scroll with the wheel up, and that's it. And well, as you can see, the current is about minus 100 milliamps. That's quite good. I remind you that ABLogger is enabled to measure absolute value of current below 100 milliamps, and you should worry only in case when the leakage current is several times higher than 100 milliamps. Here, it's all about 100 milliamps, so everything is just fine. Okay, let's zoom back. I remind you to get back to the overall graph. I just hold Alt and click, and that's it. And see, when the car is standing still with the engine off, voltage just goes down smoothly. Let's enable the graph, the marker T1, and move it all along the timeline, and we see voltage just goes down smoothly. There is no current spikes, there is no voltage drops, it's all smooth, so everything works just fine. Well, now let's check the alternator operation while the car is on the run. Well, let's select the region. I mind you, hold Alt, select the area, and then release. And well, we can zoom even more and turn off the graphs, and then let's analyze. After the engine is started, the voltage is about 14.7 volts, and that's quite stable with insignificant drops somewhere. These insignificant drops are caused by the cabin heater. It's all in April, and sometimes it is cold in April. That's it. So, as you can see, the voltage level here is mainly about 14.7 volts. So the only type of battery should be used in that car is calcium battery. If the battery is not made by calcium technology, it could easily overcharge, boil, and degrade faster. That's it. Well, now let's generate the report. Here you can see two buttons. First one is for generate reports when the device was installed on the car, and the second one is for warehouse machinery. Well, let's click. And that's it. Here's the report. There are some fields. You can type something here, print quite easily, and then there are diagnostic results. It's all calculated, and technician's notes. It is recommended to use calcium battery, and that's quite right. Well, let's analyze the second case. Click Open File and select this file. It'll load for some time, and that's it. And this is a Mercedes car used as municipal taxi in Heraklion, Greece. Well, let's analyze what we're seeing. And first of all, you can see lots of engine starts. See this negative current drops. It's all engine starts, and there's a lot of them. And by lot, I mean over 20 engine starts per day. And this number is huge, obviously. Let's check the exact value. And it's about minus 380, because yeah, that's a Mercedes car, right? Well, it's obvious that such number of engine starts and this value of current affects battery in a bad way. Well, let's analyze our writes. Okay, let's zoom to the one of the first writes. Here I hold shift, not shift, control, scale over time, and that's it. See what is happening. We've started the engine, the voltage kind of stabilized, and then we see this spikes for no reason. There are big spikes and smaller spikes. Something weird is happening. Okay, let's place a marker here. Okay, so it's about 14 volts. And now let's move along the timeline. We can see this spikes again, so the voltage is unstable for some reason. And let's move. Let's move to the next writes. See, now no spikes, just one of them. Just in advance, this car has no recuperation of the braking energy and so on. It's just a car. And here, for some reason, when the voltage is quite stable, it's above the 14 volts. Now it's 14.1. Okay, but whatever, we can move. And well, see here, this spikes again. The voltage is unstable one more time, and then we find this moment. Look, we see this voltage step. It kind of drops down rapidly. Now let's zoom to the current. We see the current is quite unstable as well. That's okay, but here there is no significant current change which can cause such voltage drop. So the voltage is unstable, and it is changing independent from the current. So there's something bad happening, and that's right. The problem was the slip ring here in the alternator, and once the slip ring was replaced, the problem is gone. That's it. Well, let's check another case. Select the file, wait until it's loaded. It'll take some time for sure, and that's it. And as you can see, it is called incorrect installation Land Cruiser 120. Well, an incorrect installation. What's incorrect? Well, let's take a look at the current graph. And as you can see, the current here is either 0 or negative. And it's negative when the engine is being started. Let's check the value. And it's all about 181 or 82 amps. That's quite okay. But we see no charge here, just discharge, or current is either 0. Why? Well, there's a reason for it. Sometimes there are cars which have more than one battery, and there are cases when several wires, like here, go to the same battery terminal, and sometimes, like here, these cases are combined. Like, look, first battery, second battery, bunch of wires go into the same terminal, and that's it. And when we install the ABLogger in such systems, we have to put all the wires through the sensor. But since we didn't, we can't see the charge, and that's why the installation is incorrect. That's it. If such cases, you try to generate a report, like clicking that button, it'll say logger has been installed incorrectly. No data on charge and currents. It is impossible to generate a report. And that's quite right, because such report would be incorrect anyway. That's it. Okay, the next case. Well, Skoda rapid car. Wait until it's loaded, that's it. And okay. Well, maybe let's zoom to the one of the first rights. I hold Alt, select the area, and that's it. Hold Control, zoom over the timeline, and that's it. Look, the volt, this is obviously a ride episode. Here, our voltage increases from about 12.5 volts up to 14.6 maybe. So definitely here we've started our engine and start riding, and during the ride the voltage is relatively stable. See, like no significant drops most of the time. That's okay. But here we've definitely started our engine. We see this voltage rise. But here we have no huge starting current, right? When we start the engine, it should consume a lot of current in order to ignite the fuel. But we see nothing. Weird. Okay, let's move to the end of the ride here. Zoom back, that's it. Let's place two markers. Let's place the first one right after the engine was stopped and we've finished the ride, T1, and the T2 should be placed right before the second ride. Okay, and as you can see here, absolute value T1 minus T2 is about 1 hour. Quite okay, but we see this huge voltage drop. Look, just after an hour of standing still, we've dropped from 13.5 volts down to 12.5 volts. That's quite weird. Why is that? Maybe we've dropped because of the leakage current? Okay, let's zoom to the here and see. I remind you the only absolute value of current, the least absolute value of current ABLogger can accurately measure is about 100 milliamps. And here we can see this flickering about 100 milliamps. So there's nothing bad happening. The leakage isn't that huge to cause that voltage drop. Well, what is happening? That's quite weird. Let's generate the report. Okay, the report is done. And see. Technician's note. Battery voltage drops below 7 volts are detected during diagnostics. And there are following possible reasons for such drops: bad battery condition, voltage drops because of poor wiring, and starter consumption is too high. Well, let's check the starter consumption then. Maybe it's too high for sure. Let's enable the marker. And look, it's just minus 223 amps. Not that high, quite okay. Okay, about the wiring. We've checked it, we've double checked it, and the wiring is okay. Bad battery condition, that's it. Why is that so? Look, here we see that the voltage dropped from 13.5 down to 12.5 volts after just an hour of standing still with no leakage current. Of course, there's some leakage current, but it's relatively small, so it can't create such huge voltage drop. So the battery is dying, and we can zoom exactly to the episode when the voltage has dropped below 7 volts. Here, see, we have no starting current, we can see it, but we can see these sampling points. These are points when ABLogger is actually performing the measurements and records into its internal memory. And see, we see points, and then we see this straight line with no points on it. And then ABLogger can measure again because the power is restored. So that's the case. The battery is just dying. It is able to start the engine. I don't know, just a miracle. That's it. The battery is dying and it should be replaced as soon as possible. Okay, the next case. Open file and select this. Let's wait until it's loaded. And here it is. Well, this is Volkswagen Touareg car, and this is an interesting case, and it will demonstrate you that there's a lot of interesting stuff you didn't know about your car before. But you will if you'll install ABLogger. The owner actually complained that the car has lots of problems related to electronics. He replaced batteries 2 times because they have been dying for no reason. And let's find out why. First of all, let's take a look at this relatively long periods of standing still with engine off. The first period and the second period. Everything looks fine except these 2 voltage drops. The first one and the second one. Well, what is actually happening? Let's zoom it in. Here. So yeah, something is going on. And here, see that drop and the corresponding current spike. Well, let's place markers and check the time. The first one, the second one, and see the time after the last write is about 5 hours. Yeah, okay, let's check the second period. Here, zoom it in and place the markers once again in order to check the time. First, second, and here. This is the same time, so it's not a coincidence. This Volkswagen Touareg car is packed with electronics and performs self-check like this. Well, let's check the leakage current. Here, auto scale, hold Alt to select the area of the graph, and then release. Use my Shift button to zoom, and then Control button, and see the value. So it is actually higher than 100 milliamps. So there's something happening, right? Okay, so leakage current is relatively high, and it is definitely higher than it should be. Well, let's zoom to another interesting periods here. There was a write, like another small write, and here it is. Looks like engine start, and then it's turned off once again. But the thing is, the owner said he did not start the engine here. And there are same episodes here. Once again, pretty long, right? And then this two starts. But once again, the owner says that he did not start the engine after a write. And why is this happening? Well, it's all about the remote start system, because the owner actually installed the remote start system. This system can start the engine remotely by pressing a button, or it should start the engine if it's cold outside to keep engine warm. This is how it should work. But as you can see, it really doesn't work this way. In order to everything works fine, the system should start the engine after a few hours of when the write is finished. But actually it starts several minutes after a write. So there's a problem. And to keep engine warm, it should work for 5 minutes straight maybe, but it really doesn't. So there's a problem. And all these things affect the battery. Let's check the starting current here. Let's place a marker and check here. It's about minus 330 amps. Okay, and the next day it's minus 450 amps, and then here it becomes about minus 500 amps. So yeah, that's why the batteries are dying. So to fix all these mad things happening, the owner should contact the service where the remote start system was installed. And of course, it'll be good to check electronics in general. That's it.